Hello and welcome to this video. This is lesson 6. We're going to talk about radians in our unit 6 on circles. Our agenda in this lesson, we will cover the unit check-in, our guiding question for this lesson. We'll talk about what is a radian, try some practice questions, and then I'll leave you off for the Excel work. So we are on lesson 6 of our unit. We've got one more lesson after this. We're going to talk about the equation of a circle. After that, we'll have a review and a final exam. Our guiding question for this lesson: why are there 360 degrees in a circle? I've always told you that in a circle there's 360 degrees. But why? Why that number? And are there any other ways of measuring angles other than degrees? That's what we're going to talk about in this lesson. So what is a radian? So a radian is in fact another way of measuring angles. While using degrees is useful in engineering, radians is actually much better for mathematics. So by definition, a radian is the angle formed, so this angle right here, formed whenever you take the radius of a circle and lay it out as an arc. So if you take this radius and you lay it out as an arc, you get an angle, and we define that angle as 1 radian. So it's another way of measuring measuring angles. So how many radians are there in a full circle? Well, if you take the radius and you lay it around the circumference of the circle, you can lay it once, twice, 3 times, 4 times, 5 times, 6 times, and a little bit more. To figure out exactly, you have to remember that the circumference of a circle is given by 2 pi r. So what's 2 pi r divided by r? It's actually 2 pi, which is a little more than 6. So there's a little more than 6 radians in a circle. So a full circle can be 360 degrees or 2 pi radians. 2 pi radians. The formula for finding arc length in radians is actually simpler than the one for degrees. Here's the old one. We have theta, which is our angle, divided by 360 times the circumference, 2 pi r. But if we replace 360, which is equivalent in radians, 2 pi, then the formula simplifies. L equals theta over 2 pi times 2 pi r. Well, the 2 pi here and the 2 pi here will cancel, and I'll just be left with L equals theta times r, where theta is in radians. So let's try an example. I'm going to write my formula first. It says the radius of a circle is 1. What is the length of an arc? So we're looking for L, the length of an arc. That subtends an angle, and now it gives us a measure in radians, 19 pi over 24 radians. Now this looks like a crazy number, but radians usually has a pi in it. That's why you see that. So L equals my angle, 19 pi over 24 times my radius, which is 1. Well, that just equals 19 pi over 24. So that is actually my answer. Pretty easy. Okay, very similar question. The radius of the circle is 10 yards. What is the length of an arc that subtends an angle of pi radians? So the angle is pi. So remember, my formula is L equals theta times r. So L is going to equal my angle, pi, times my radius, 10. So the length of that arc is 10 pi. As you can see, this is much simpler than the other one. Alright, let's go in reverse. So this says the radius of a circle is 10. What is the measure in radians of the angle subtended by the arc? So now we're looking for theta. Let me write my formula one more time. I know L. L is going to be 10 pi. I don't know theta, and I know r is 10. So all I have to do is simply divide by 10, and I see that my theta has to be pi. Pi, and that's in radians. Just as simple as that. Alright, so that was it. If you want more of a challenge, check out the extension activity titled Radians Extension Activity, the unit circle, and let me know if you actually answer that question. The IXL for y'all to do is called Geometry. It actually doesn't have a number. You'll see it on IXL. Geometry U, and then it's called Radians Arc Length, and it says New. That's the one you need to work on. Please be sure to send me an email or join me during my office hours on Zoom with any questions. Best of luck.